Hey, welcome back to Fat Mama Physics. In this episode, we are on Unit 3, Polynomials. This is section 3.1, where we're just going to introduce the idea of what is a polynomial, what are some terminologies, and what are some basic concepts that we should be aware of before approaching this unit. So, the biggest one that I will model with, of course, a board game at the beginning of every lesson is the idea of like and unlike terms and how it is important that we can categorize them before we can add them, subtract them, etc. So, and of course, the company board game that I have, it has to do with that. So, I'm going to turn it over to my other camera. Alright, so 5 tribes. Here we go. Here's the cover. This is what it looks like. Very pretty art. A little bit controversial in some subject areas, which you'll probably see in a second. So here is what the board looks like. It is composed of these tiles and a bunch of meeples. There's 3 meeples at every tile. These are all ranged randomly, of course. So that's the, just so to make the map different every single time. Here's some other components in the game. So here I have a set of market items, which then here is the beginning of the market. Order matters. This is going deeper into the market. Over here, I also have some genies, which can be purchased. And of course, a genie is going to always require a pretty much white meeples. So white meeples help you access the genies, and the green meeples help you access the market. And, so there's some other meeples at play here. They help you do different things. Yellow meeples are pretty much, they count as points at the end. So, not very exciting. The red ones are, they help assassinate people for you. So they actually help you claim land, which I will show us, I guess, in a moment. And the blue ones are builders. The builders basically activate the tiles in a way so that helps you claim points, especially the tiles that have the blue circles on the side. So that's the meeples. Every tile also has an action associated, which we can talk about some examples. So let's see. What does this game do? It's played between 2 to 4 players. I prefer the 2 people variant because it gives you 2 of these action pucks as opposed to just the 1. The reason having 2 is very fun. I really like that because you can chain up your turns depending how you bid. So for example, let's say blue bids 5. And then let's say pink decides to bid, let's say 1, for example. Then blue might say, hey, well, I can just bid 3 and just go right after one another, and then yellow and then pink can bid 0 because there's no point bidding anything higher. Or unless pink thinks there's a really good move, yellow might bid a little bit higher. But either way, the purpose of this track is to determine turn order. And then in this setup, the blues go twice, and then the pinks go twice, with their turns back to back. Very powerful in some circumstances. So what is this all about? How does this have to do with matching like and unlike terms? So the blue here is going first, and they do have a very nice advantage. So what could they do? Well, one way to claim points is to empty a tile. You empty a tile by kind of collecting all the people there, not by emptying a tile. So this is what I mean. Let's say I take this batch of people here, that's blue, and then what blue's going to do is the blue's going to move 1 tile at a time orthogonally, not diagonally. So let's say he moves here, he has to drop a person. It doesn't matter what he drops to begin with. And then let's say he goes here, he drops another person, and then he wants to end up here. Notice the last person he's going to drop on this tile has to match exactly the one of the colors of the people on this tile. Now, it doesn't have to be all of the same color. He could have also dropped this guy, let's see, he was here. Actually, that was the only legit move he could have made. And you can't go backwards, so I guess, yes, he can only go here. But he doesn't need all of them to match. As long as one is matching, then that's fine. But the good thing about this is that after he matches he matches at least one color, then he takes every single meeple of that color on that tile off of that tile and allows him to claim it. Claims that land. Normally you can't do that if you have meeples remaining. Note he doesn't claim this tile over here because that's where he left off of. That doesn't count. So what happens when he does that? Once he matches a bunch of meeples of the same color, he gets to perform that action. So in this case, I wish I used green instead of red, but you know what? Let's make that happen. Okay, I kind of cheated. I just swapped them with green. But anyways, I just wanted to show us what the green does. The red assassinates people, which is a little bit, I guess, in the beginning of the game, less interesting. So let's say he takes 4 of these green guys, which looks very nice, because what happens, he gets to access the market, he picks the top 4, and then this is all his to claim. So he gets all 4 of these things. Okay, so that's what happens. First, you get some meeples, and then you activate whatever action is on the tile, which is putting a palm tree down. This is very nice, because the palm tree actually makes this tile worth more. So his point value that his camel is sitting on is going to be higher, which is great. Okay, so that's a nice opening move. And then blue gets to go again. Okay, so again, he has to match, again, a color. And I guess maybe I'll do is I'll show us how the genie works. Because the genie, genie is really we all love the genie. But keep in mind, to get the genie, we need the white people. Okay, sounds very racist here. But anyways, the white meeples, we need, ideally, we need one of these genie spaces with the white meeple on there in order to have white meeples to buy a genie. So it looks like this is a good tile because it's got 2 white meeples, and always more white meeples the better. So what we can do is we can take this pool of people, and then we can say drop 1 as we go here. And don't forget, we can always loop around. So I'm going to loop around here. And I'm going to collect 3 of these white dudes, and you keep them until you spend them. So then he's going to spend maybe 2 of them, and keep 1, and buy a genie. And this genie is really fun. I really like this guy. What this genie does is, taking a look at the icon here, you get to take 3 random meeples and put it onto an empty space by spending whatever's on the top here. So that's a white meeple. This one over here, also very controversial, but that is indeed, it's actually a slave. And slaves can be purchased at the market. So here we go. This is very powerful near endgame, especially when the board has been pretty much cleaned out of meeples. So that's basically kind of the gist of the game. And why does that have to do with matching like and unlike terms is because every time you land on the tile, you have to match at least one color from the pool that you've brought in. So it's like their friends meet up somewhere and does a specific action on the tile. So that's kind of thematically kind of how it works. So cool little game. A lot of strategic plays. There's many ways to loop, build up a pile of meeples that allow you to have a longer range and allow you to loop around. And remember the red meeples I talked about can allow you to assassinate. So if you assassinate this guy, then technically you can claim that tile. So lots of different strategic moves. Great 1v1 game. I love playing this with my partner. It's a game of wit and just planning and strategizing. Very fun. Okay, so here you go. 5 tribes and back to modeling polynomials like terms. Thank you for checking this game out with me. Alright, looks like we are back. So, let's get started and doing some math here. Alright, so most of this lesson is just getting us accustomed to the wording of different terms, because without knowing the terms as much, we won't be able to move forward into the rest of the unit. Alright, so here we go. What is a polynomial? Here is our definition of a polynomial. So it basically is a collection of terms, which there might be numbers, there might be variables in there, but they have exponents that are only whole numbers. So positive integers, not 0 and nothing that is a fraction, and nothing that is a negative, and of course no negative fractions as well. So what does that look like? Here we have an example of a polynomial. So there's variables in here, there is these numbers here that are beside the variable, and we have these terms that are hanging out on the side that don't have any variables attached. So a number here that is like a 3, anything that is beside a variable, these are called coefficients. So here we go, we have a coefficient of 3 here. And notice that in front of this x, there's also a coefficient. You might be tempted to say that's a 2, but we also have to factor in there's a negative sign in front. Even though it means to subtract that, we still say that the coefficient, we treat that as a -2 for the coefficient. Okay, so anything in front of a variable, we call it a coefficient. Any number that is hanging out by itself, we call that a constant. So this 5 over here is a constant, while the ones that I've touched in green are called coefficients. Okay, so let's erase that. Usually when we write a polynomial, we have the variable with the largest exponent written first, and then writing them down in descending order. So keep in mind that not all polynomials are going to have an x to the power of 2, and then having the variables with all of the different exponents. What I mean is you might see something that looks like this. This is also a polynomial. Okay, it's just as long as it has a variable to an exponent, this is classified as an exponent. As a polynomial, okay? Now, what are some things that we call these polynomials? For example, this one that we have here, notice that x to the power 2, the 2 exponent is the largest exponent on this entire polynomial. This means that we give this polynomial a name, and we call this is a polynomial with a degree of 2, and 2 is the number on the exponent, okay? So not the 2x, because that would be a 1, imaginary exponent of 1, which is not the case, and definitely not the 5, because 5 is not a variable. Okay, so that's one thing there. There are some tricky examples where, let's say I have something that looks like this: 3x squared y plus y squared minus, I don't know, xy. All right, so let's say this was my polynomial. And yes, you're allowed to have 2 variables, whatever. It's just a mishmash of unknowns, we just have to be comfortable with the unknown. And if we have to determine the degree of this polynomial, many of us might say, oh, this is going to be 2 because that's the largest exponent on my polynomial. However, we have to be very careful. In cases where there's 2 variables or more, we have to consider the sum of all of their exponents, in which there are these imaginary exponents of 1s on these variables, so that the sum of the exponents in our first term is actually 3. This is 2, and this is also 2, which means the degree here is actually going to be 3. Because we have to add up all of the individual exponents of all the different variables in that particular term. Okay, so that's something we have to be careful of. Okay, so that's degree. What is something else we want to take a note of? The idea that some polynomials may come in 1 term, 2 terms, or 3 terms. So a term, the idea of a term is very important. So a term is something separated by a plus or minus sign. Okay, so for example, here we only have 1 term. Okay, this is only 1 term because there's no plus or minus signs. This is 2 terms, 2a, and then plus 5, separated by a plus sign. Here we have 3 terms. Here we are separated by minuses and plus signs. The polynomials that have 1 term are called monomial, just like something is monotone, the same tone, only 1 tone. Binomial, like binary, 2. Trinomial, like triangle. Okay, so that's for 3 different terms. Let me give you a scenario where terms become important. to differentiate. Let me give you a situation here. So here I have a really complicated polynomial here. It looks very ugly. You never want to solve anything that looks like that, but maybe you do have to do that one day. So my question to you is, how many terms do you think this is made of? Good time to pause the video. One thing to be mindful of when dealing with this is that with these brackets, whenever you have something that's side by side, that means to multiply one another. So I have technically 3 times x squared times whatever is inside these brackets. And to be honest, we don't really care what's inside these brackets. It's a bracket. There's stuff inside that we're just multiplying them. So in fact, because every single thing in here is multiplying, this whole thing here is actually one term. Aha! So it's not 2 terms. You might be tempted to think that there's y plus 1, that must be 2 terms. This is only 1 term. That's only 1 term. This is separated by the minus sign. 4 times y squared, this is 1 term. And plus 1, this is a separate term. So a total of 3 terms only. Okay? So it is very important to be able to know your terms, what is a term and what is not a term, especially this unit and in algebra, okay? Alright, the last but not least, I'm going to tell one more thing in this video, and I'm going to relay everything off to the next video. So the last but not least thing that we have to talk about of what is a polynomial and what is not, is we have to be careful of when whenever you have a variable that is in the form of a fraction where the variable is in the denominator, or you have any sort of a square root, that also is not a polynomial. And that is including anything that is a radical and also as a fraction. So these are all not polynomials. And the reason why is not something you would know at this point, but if you paid special attention to the previous episodes where we talk about exponents, I may have alluded to the fact that if you have anything that is in a fraction like 1 over x, this is x with a negative exponent of -1. I've also maybe touched on the fact that if you have a square root of an x, this is technically x with an exponent of a fraction. And a half per se. So remember the definition of a polynomial is the variables must have whole number exponents, and of course these do not fulfill that requirement, thus are not polynomials. Okay, so I like how in this video I never even got to like and unlike terms, so unfortunately we just have to call it a day, because I talked quite a bit, okay? So that will be the conclusion of this video, part 1 of 3.1. Thank you for watching, and stay tuned for part 2, Fat Mama Physics, signing out.